Hello class 11 science. In our last class, we have discussed about concentration terms like weight by weight percentage, weight by volume percentage. Then after that we have seen normality, what is it? And after that we have seen the molarity. Okay, molarity. That is the number of moles of solute per liter of the solution. Okay, that was molarity, denoted by capital M. Now today we are going to discuss about the left concentration terms. So for example, molality. The previous that we discussed was molarity, and this is molality, and it is denoted by small m. It is defined as the number of moles of solute dissolved in 1000 gram of the solvent. So whatever number of moles we take in 1000 gram of the solvent, that will be the molality, and it is given by number of moles of solute by weight of solvent in grams into 1000. Okay, sometimes it is also mentioned as, it is defined as the number of moles of solute for 1 kg of the solvent. Next we have got mole fraction, a very important term, denoted by small x. It is defined as the ratio of the number of moles of one component to the total number of moles of substances in the solution. So mole fraction is defined as the number of moles of that component, because in solution we have got 2 or more components. So in that case, it is defined as the ratio of the number of moles of one component to the total number of moles of substances in the solution. This will be clear with the expression that we need to see. Say for example, if you take a binary solution, contains N1 moles of the solute and N2 moles of the solvent. In solution we have got always 2 parts, one is solute and other is solvent. Solute is the part that get dissolved and solvent is the substance that helps to dissolve. So if you take N1 as the number of moles of solute and N2 as the number of moles of solvent, then we can write mole fraction of solute, that is x1, will be equal to number of moles of that component, that will be N1 divided by N1 plus N2. So this will be the mole fraction of the solute. Similarly, for mole fraction of solvent, x2 will be given by number of moles of that solvent, that is N2, divided by total number of moles of the substance, that is N1 plus N2. And we need to remember that x1 plus x2, that is the mole fraction of solute plus mole fraction of solvent, is always equal to 1. You can just simplify it. If you just add this term and this term, you will get 1. So mole fraction, that is the sum of mole fraction of the component of the solution, is equal to 1. Next, and one more thing that we need to know is, number of moles can be calculated by the formula weight in gram by molecular weight, that we'll see. So here we have got the numerical based on the mole fraction. The question is, calculate the mole fraction of water in sodium hydroxide solution which has 80 gram of sodium hydroxide and 54 gram of water. Relative atomic masses of sodium is 23, oxygen is 16 and hydrogen is 1. Now what we need to do and how we need to proceed. So first we will write down the number of moles formula. Number of moles is given by weight in gram by molecular weight. Atomic masses are given, that means you need to calculate the molecular weight or mass that we have seen in our previous classes. So molecular weight of sodium hydroxide will be 20 plus 16 plus 1, that will come as 40, and molecular weight of water is 18. Okay. Now according to the formula of number of moles of water, that is N1, can be weight in gram by molecular weight. So weight in gram is 54 gram, it is given in the question, by 18 molecular weight. So it will come as 3. Similarly, number of moles of sodium hydroxide, the value for N2 will be weight in gram, that is 80 divided by 40, that will come as 2. So we got the number of moles of water and number of moles of sodium hydroxide. Now mole fraction of water you need to find out. So mole fraction of water, that is x1, will be equals to number of moles of that component N1 by N1 plus N2. So N1 value is 3 and this is 3 plus 2, that is 3 by 5, which will come as 0.6. This will be the mole fraction of water. And if you need to find out the mole fraction of sodium hydroxide, you can find in a similar way, and its value will come as 0.4, because the addition of this 0.6 and that one should come as 1. Or to get the mole fraction of second component, what you can do is you can just subtract this 0.6 from 1. Okay, there you go. Now your assignment for today is a solution to be used in hand lotion is prepared by mixing 90 gram of water, 9.2 gram of ethyl alcohol, the molecular formula is C2H5OH, and 18.4 gram of glycerol, C3H8O3. Calculate the mole fraction of glycerol present in it. You need to find out the mole fraction of glycerol. Remember that in this case you have got 3 components, so you have to find N1, N2 and N3. Okay, and relative atomic masses of the elements are given. Carbon, hydrogen and oxygen are given. So that was question number 2. Question number 3 is 20 gram of sugar, that is the molecular formula C12H20O11, are dissolved in enough water to make a final volume up to 2 liter, and you are asked to find out your molarity of the solution. So you have to go to the definition of molarity, and from there we use the equation and calculate the molarity of the solution. Complete it and send it in email.